Hi guys, we have made it to the last unit, which is all about something called square roots for the most part. So let's jump into it. So in the past couple units, we have learned that squaring a number means using that number as a factor twice. What do I mean? So if you had 4 squared, you know that means 4 times 4, based off of what we did with exponents. So what we're starting today is square roots. So the opposite of squaring is finding a square root. To do this, you must find 2 equal factors, or just 2 equal numbers, 2 numbers that are the same, whose product, which just means to multiply, is the number in question. So what does that mean? If you had, forget about this for a minute, the square root of A equals B, that means this B times B equals A. This right here is called the radical sign, or the square root sign. There are such things called the cube root, the 4th root. You can take any root of a number that you want, the 100th root. We're only going to do square roots, which means we're looking for a number times itself to give us that number under the radical sign. So let's jump into this. Simplify. Number 1, square root of 49. So we're looking for what number times itself gives you 49. And so hopefully you're going to think 7, because 7 times 7 is 49. So my answer to this question is 7, because 7 times 7 is the number under the radical. It's 49. Number 2, we have the negative square root of 49. So forget about the negative for a second, and we just did the square root of 49. You told me, or no, I told myself, the answer is 7. When there's a negative in front of it, that just means take the opposite of the square root of 49. So you're going to just put the negative in front of the 7. So my answer here is negative 7. Third situation is a negative inside the radical sign with the number. So we're looking for, remember, a number times itself to give you negative 49. So what most people, they'll say, oh, a negative 7 times a negative 7. Well, negative 7 times negative 7, that equals positive 49, not negative 49. Then people usually tell me, oh, negative 7 times 7 is negative 49, which is true, but these two numbers have to be exactly the same, sign and all. So there isn't actually any answer to this. What I rate for this is, what should we write? Undefined. We'll write undefined for our purposes. Meaning that anytime you have a negative under the square root sign, your answer is undefined. When it's outside the radical, like right here, you just stick it in front of the number. Let's look at one more example similar to this. So square root of 25. You're looking for what number times itself gives you 25. And that number is 5. That's my answer. Number 5, if we asked for the square root of negative 25, so that means what number times itself would give you negative 25. This is the same thing as number 3. Some people would tell me negative 5 times negative 5, but that gives you positive 25, not negative 25. So it's not this one. Then people will tell me negative 5 times 5. Well, that does give us negative 25, but these two numbers, negative 5 and 5, are not the same. So this is another one where we would say undefined. We wouldn't say no solution just because we're not actually solving an equation. And then number 6, this is like number 2. Hide the negative in front. What's the square root of 25? It's 5. And then this negative just comes in front. Take the opposite. This means take the opposite of root 25. So the two numbers 25 and 49, they are part of a special group of numbers which you may have heard of before called perfect squares. And I'm going to post kind of like a cheat sheet of perfect squares under the notes section after this video. So just to run through it, 1 squared is 1 because 1 times 1 is 1. 2 squared is 4 because 2 times 2 is 4. I won't say this for every single one. 3 squared is 9 because 3 times 3 is 9, etc., etc. So all of these numbers here are your perfect squares. I stopped at 15, but I can go up to 1,000, 1,000,000, which wouldn't even make sense, but I can square any number that's a whole number, or actually an integer, and get a perfect square. We're not going to get into negatives at the moment. Okay, let's look at number 7. So 225. Now that one is on our list, but let's say that we didn't know. Again, we're kind of assuming if we were in class, we wouldn't have a calculator for this, so we're going to be wanting you to show your work here. And so 225. So what you want to do, some of you way long ago may have remember making number trees or prime factorization. So I'd like to just run through that with you. You might have done that in middle school. So 225. You are trying to find a prime number. Remember, a prime number is a number, is a whole number. Should have had this written out before. A whole number that has only 2 factors, itself and 1. Okay? So meaning it only has 2 numbers that go into it, itself and 1. One example of this is 3, the number 5, the number 7, the number 11, because the only 2 factors are 1 in itself. So your goal is to find a prime number that goes into 225. One of those numbers is 3. 3 times 75 gives you 225. Again, this is called a number tree or doing the prime factorization. There are different strategies for this. I always tell people once they have the prime number, circle it. The other number, you have to keep factoring it down into prime numbers until you can't go anymore, meaning until you have all prime numbers. So 75, I can think of that as 3 times 25. Up, there's another prime number. 25, I can think of as 5 times 5. Up, 5 and 5. Those are prime numbers. So the prime factorization, for those of you who want to see that written out, you're like, how is this helping me? For this number here would be 3 times 3 times 5 times 5. And let me show you how that helps you. That means I can write 225 as 3 times 3 times 5 times 5. Well, what's 3 times 3? 9. What's 5 times 5? 25. And so, when I am multiplying 2 numbers under the square root, you can separate those and take the square root of each number. So what's the square root of 9? 3. What's the square root of 25? 5. 3 times 5 is 15. So that's using prime factorization when we're not just using a calculator, and we would expect to see this work on your homework tonight. Let's look at another one, 576. Let's go through the prime factorization of it. So 576, you could start a lot of places, but some people might say, well, again, you could start with a prime number that goes into 576. You might say, well, it's even, so I could think of that as 2 times 288. 2 is prime because only 1 in itself are factors of it. 288, I mean, you could do 2 again. That's not wrong. I was just trying to find a larger number, but we can do 2 again. That's okay. So 288 divided by 2, that's going to give you 144. 2 is prime. Circle it. 144. Again, you're trying to find prime numbers each time. So if you're just kind of stuck on the 2 because it's even, go for it. So 2 times 72. 72 is even. So I mean, if you really want to, hey, we can do 2 again. 2 times 36. Again, circle the prime number. 36. You could divide by 2 again. This time you might change it up and say, oh, 3 times 12. Okay, circle the 3 because it's prime. 12, you could go 2 different ways. You could say 2 times 6. You could say, what was I going to say? 3 times 4. I'm going to go the 3 times 4 root. And then lastly, I have a 2 and a 2. So the prime factorization, how many 2's do I have? 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5, 6, and then how many 3s? I have 2 3s. Let's just kind of wrap this up here. 3 times 3 is 9. And what's 2 to the 1, 2, 3, 4, 5, 6th power? 2 to the 6th power, if you do that out, that's going to be 64. So really, I can rewrite 576 as 64 times 9. So what is the point of the prime factorization for those of you who are like, why is she doing this? It's to rewrite the number that you're given when it's too large to figure out what the square root of it is. So like we said in number 7, we can break this up. When I'm multiplying two numbers under the radical, you can take the square root of each. The square root of 64 is 8. The square root of 9 is 3. 8 times 3 is 24. And if you check, 24 times 24 is 576. So that's number 8. Let's look at number 9, 324. I'll do another one with the prime factorization. Okay, so 324, you might be like, oh, it's even. I'm going to do that. You could also do 3. I'm just going to do 3 because it's a little bit more quicker, not by much. So 3 is prime. I'm going to circle it. 108. I'm looking for another prime number that goes into 108. 3 is another winner. 3 times 36. 36. 3 goes into 36. I just did that. Times 12. We know 3 goes into 12. 3 times 4. And then I rewrite 4 as 2 and 2. So 324. How many 3s? 1, 2, 3, 4. So I have 3 times itself 4 times. And then 2 times 2. So let's just do a little bit of math. So 2 times 2 is 4. And 3 to the 4th power is going to be 81. So really I can rethink the square root of 324 as 81 times 4. When I am multiplying two numbers under the radical, we can take the square root of each. The square root of 81 is 9. The square root of 4 is 2. 9 times 2 is 18. And if you check on your calculator, 18 times 18 is 324. Okay, we're almost done. Bear with me through this. Fractions kind of behave the same way. If you have the square root of a divided by b, that means you can just take the square root of a and divide by the square root of b. So 81 and 21, those are kind of square root perfect squares that we need to get to know. Some of these are more common than others. But I can think of this as the square root of 81 divided by the square root of 121. Square root of 81 is 9. Square root of 121 is 11. And you're done. 9 divided by 11 cannot simplify. Next one, number 11. Square root of 64 over 81. Think of that as the square root of 64 divided by the square root of 81. The square root of 64 is 8. Square root of 81 is 9. You're done because 8 divided by 9 does not simplify. 12. 2 ways to go about this. I'll show it 2 ways. Keep going with what we've been doing. Square root of 36 divided by the square root of 4. Square root of 36 is 6. Square root of 4 is 2. You do need to simplify this because 6 divided by 2 is 3. That's one way to think about it. Another way to think about it is simplify the fraction first. 36 divided by 4 is 9. So really, you're just taking the square root of 9, which is 3. Either way is fine. Okay, then on your homework you might see some with decimals. And so with decimals, I recommend you rewrite it as a fraction. So this is 16. This goes back to like your pre-algebra days. How do you go from a fraction to a decimal and vice versa? So I'm at the 10th hundredth place. So I am rewriting 0.16 as 16 over 100. And then I can go ahead and take the square root of the numerator and the denominator. Square root of 16 is 4. Square root of 10 is 100. This will simplify when I divide each by 2 to 2/5. There's my answer. I recommend doing it this way. I've seen it done different ways. So same deal this with the negative we saw at the beginning of the lesson. That negative is going to come down with us through the whole problem. I have 25. So I would not write 0025 because that's not how we write numbers. We just have 25 and then we count out to the last spot that our number is in. So this is the tenths, hundredths, thousandths, 10,000ths. So that means this is 25 divided by 10,000. I bring down my negative again, and I take the square root of the numerator divided by the square root of the denominator. Okay, square root of 25 is 5, and square root of 10,000, you're looking for what number times itself gives you 10,000. And if you think of the number of zeros, you have 4 of them, so cut that in half to get 2 zeros. It's 5 over 100. So my answer is negative 1 over 20. So there's a little bit of different problems similar to what you will see on the homework tonight.